So hello everyone. Today we are going to discuss questions of first five questions of Codechef Starters 82 round Div2. So let me share my screen. First of all, am I audible? Hello guys, am I audible? Yes, fine. So the first question is min to max problem, in which we have to choose a minimum value. We have to make minimum value to be the maximum value of the array. For that, we have to perform some operations. In an operation, we have to choose an element ai, any element from the array, and another integer x, and set that integer to be x. So we have to determine how many minimum number of operations are required to make m the maximum value of the array, that is the minimum value of the array to be the maximum value of the array. So first of all, we will sort the array. So as you can see from the code, let me open it in VS Code. So first of all, there are t test cases which we have taken. Then we have inputted c in n. Then inputted the array. Then we sorted the array in increasing order. So the first element of the array will be the minimum value, and we have to consider all the initial values which are equal to the minimum value. All the values which are not equal to the minimum value will be the number of elements which are not equal to the minimum value will be the answer of this question. So first of all, we have initialized the answer to be n minus 1, that is total number of elements apart from the minimum number, apart from the first element of the sorted array. Then while we then from the starting we are seeing how many of them of the initial values are equal to the minimum value, and we are decreasing the answer uh, according to that. And once we got another value which is not equal to the minimum value, we are breaking it. So in this way we are actually selecting all the number of minimum value. We are actually decrementing the answer by the number of elements which are equal to the minimum element of the array, and finally we are outputting the answer. So in this way we can solve the min to max problem. If you have any doubt, please let us know. Is it clear, or should I explain it again?
Clear.
Okay, great. So now let's move on to second question.
Okay, so now moving on to the second question. The second question is difference matrix. The question is that you are given an integer n and you need to print an n cross n matrix such that each element is unique from 1 to n square. So we have n square elements, and the absolute difference between the elements in neighboring cells is strictly greater than 1. That is, and also we have given the definition of neighboring cells, that is, they have a common side or a common vertex. So each cell has at most n 8 at most 8 cells. So I think the question is clear. So here we can actually find any pattern, like you can print any pattern. So the pattern which I found out, I will show that to you. Okay, let me use the screen for that. Yeah, okay, so here if we are given any matrix, it is this big. So what we can do is, starting from the first cell, we can write here a 1 and then leave a cell blank, and then fill 2 in the next cell, again leaving a cell blank. We will write here 3, again leaving a cell blank. So like in this order, for the first row we don't have any cells violating the condition, that is adjacent cell having adjacent elements. And from the second row we can again start from 5, 6, 7, 8, and going like this. We can fill the entire cell up to the last, and then suppose we end here at what is 7 cross 7 matrix. So like we have here 13 and then 17, 21, 23, 24, 25 and 26. So we can start from 27 here again from the top, 27, 28, 29. So like in this order you can fill the entire cells and it will not violate the condition. So let me show you the code for this. Yeah, so here we have the code for this. Like we start the solve function, which is called for every test case, and in the start we take the input n and we make a n plus 1 cross n plus 1 matrix. That is just for one indexing. You can make an n cross n matrix also. Then looping from 1 to n, I is for the row, and j starts from 1 and j is plus equal to 2. That is, it iterates at every odd columns, and we do it matrix of I of j equal to k plus plus, and k is our initial variable, we set it to 1, and then we do a loop for the even columns. So now our matrix is filled with all the values, and then we simply loop and print the values of the matrix. So it is clear, or there are any confusions in this? Okay, so now we'll move on to the next question.
Now move on to next question. Make A B same. The given question is, you are given two binary array A and B, each of size n greater or equal to 3. You can perform following operation on A. Select three indices I, j and k. I greater than 1 and less than equal to n, j greater than I less than k, and k greater than j and less than equal to n. Set aj is equal to bitwise OR of ai, aj and ak. Determine whether it is possible to convert A to array B by applying any number of given operation. Note, binary array each element is either 0 or 1. Let's array A and array B 1, index 1 index here index 1 we cannot change, and index n minus 1 n we cannot change, and here index n and index 1 is same, but middle index we can change. So we can change only array A, do not change array B. So we try to equal A and B. The second element, second index is same, third index is not same. So we try to equal element of third position. So we choose I is equal to 1 and j is equal to 3 and k is equal to 5th. Then a3 is equal to jar of a1, a3 and a5 is equal to 1. So we set bit 1. We try to index we try go on index 4. So we try to equalize, but we do not try we do not make equal, because we do not change value of 1 to 0 by OR operation. Then the answer is no for this array. Let's move on next example. In array A, all elements are 0, so we cannot make any element equal to 1. And in array B, 2 elements is 1, so therefore answer is no. So like basic to condition for no answer. Baki all other condition we satisfy yes condition. The code for this question is first we take input of a1 array A, and we check all elements are 0 or not for array A. फिर we take input of array B, which we check condition of 0 1. If array A 0 and B 1, then we can make it equal, and if condition is A1 and B0, so we cannot make, and we indicate here answer is equal to indicator, the indicator equal to 1, or if answer is equal to 0, so yes, or otherwise no answer. It is clear? Let's move on. Next question. Find e to the power ex. The problem is chef has 4 positive integer a, b, c and d, such that a % b is equal to c % d. Here a % b means a modulo b. The find the smallest positive integer x such that a plus x % b is equal to c plus x % d hold. It is granted x exists. Here test case 10 to the power 5 and a b c d 10 to the power 9. It is given that a % b is equal c % d. In this question only 2 answer possible. One answer is equal to 1 and other answer is LCM of B and D. LCM B and D minus remainder. The code for this question. We take input n is equal to 4, n is equal to 4, and we try to take input in array, and answer is equal to remainder, and we check condition for 1, answer 1, and we check for LCM minus answer, like this. Is it clear or any doubt? Can you please your previous question once again? Okay. Any doubt in this question?
ए बी का कोड तो यहाँ. Okay, so any doubt in this question? Make A B equal. That is, we are selecting 3 indices and setting the middle element to the bitwise OR of all the 3 elements. Okay, so moving on to the next question. Yes, so the next question is make them alike. Here we are given a permutation of length n and an array of size n and also an integer m. So we are given the condition that initially all the elements of array are in the range 0 to m, and we need to replace all the zeros in array A with positive integers less than m. So now the array A will be from 1 to m, and this array A dash, we'll call it, will be transformed according to the following n steps. Like in the ith step we set ai to the a of pi, that is permutation. From the permutation we take the index of I. So we apply this transformation to a, and now we say that a dash is beautiful if after the transformation all the elements are equal. So, and now we are replacing the values of 0 in a, right? So we are asked that the number of beautiful arrays, like one value we are replacing the 0 with, consider suppose 1, so we get an a dash, and now if we replace it with 2 we get another a dash. So now we need to print number of such beautiful arrays a dash. So the method for this is very simple. Like I will explain it to you with the code. Let me open it. Yes, so here we have the code. So like in the solve function we first take all the inputs here, n, m, the permutation and the array, and here I am counting the number of total zeros in array A. So here in this variable, this line sets the variable equal to 0. So now finally after all the input we have the number of zeros stored in total zeros, and all these arrays are one indexed. Note that. And now we are making a transformed array, also one index from 1 to n, and here I am just setting the default values. It is transformed of I equal to I from 1 to n, and this for loop applies the transformation, that is ai equal to a of p of I. And like, okay, let me explain it to you. 1 second. चार्जिंग कम है. Yes, so consider we are given the permutation 2 3 1 7 6 5 4. Okay, yeah. So here we have permutation and consider the array. Let's just say the array is a1 a2 a3 a4 a5 a6 and a7. So now here if I apply the transformation, let's say this is a dash for understanding. So after the transformation, at the first step I do a1 as a of p of 1, that is a2 here. So I have a2 here, and then I set a2 equal to a3 in the second step. So I have here a3, and then in the third step I have a3 equal to a1, and a1 was already set to a2, so I have a2 a3 a2 here. And similarly applying forward, I get a7 a6 a6 and a7 again. So this is the array. So now if we make an observation here, I don't care what the values of a1 and a4 were initially, because this is the final array and I only need to make all the variables in this array equal. That is, I need a2 equal to a3 equal to a6 equal to a7. So now here we can make some observations like what are the number of zeros in here, because I can change their values, and what are the numbers which are not equal to 0. Like if I have a2 not equal to 0 and a3 also not equal to 0, then I need to compare a2 and a3, because I can't change their values, so they must already be equal or the number of beautiful arrays is 0. I cannot make any beautiful array by replacing all the zeros. So here if we have any non-zero numbers in the final array, so they all must be equal. Non-zeros must be equal, and the zeros I can change to anything, like if there are like 4 zeros and there is a non-zero which is equal to 2, so I need to make all the zeros equal to 2. And if there is not a non-zero number in the final array, like all the a2 a3 a6 a7 are equal to 0, so then here I can make them equal to anything from 1 to n. So that is the constraint, like I have to change it to 1 to n. So now this is a question of p and c. Like initially I had total zeros, number of zeros, and in the final transformed array I have 0 number of zeros. So I check for a non-zero to exist. So now let's move on to the code, so you can understand better from the code. So now in the code, till this point we have that transformed array. Actually this is an array of indices, okay, it will represent the final indices. And then we have 0 and a non-zero number. If it exists, then what is it? And visited. Okay, so now we iterate from 1 to n, and transformed of I is just an index from array A, the input array. So okay, if I have not yet visited this index, then I turn the visitor equal to 1, that is I am already taking it into consideration. And then if a of I at this index, that is a of transformed of I is 0, then I increase the count of 0. Otherwise, if it is non-zero, then I check that I already have a non-zero number in the array or not. If I don't have a number, that is it is still equal to -1, then I set it to the non-zero number, which is the current number. And at any point if I get a non-zero number, then it is set to that, and if I get a second non-zero number, then it gets checked with the previous one, so they must be equal, or it will just print 0 and return. So at the end of it, I have number of zeros in the transformed array. So what I do here is take the total number of zeros initially and subtract that. So these are the total number of zeros, which can be changed to anything because they don't matter in the final transformation. Like whatever their value is, it doesn't come in the final transformation. And +1 for all the group of zeros in the final, because they must be equal. And so if I have non-zero number, then the final group of zeros in the transformed array, I subtract them because now their value is fixed, which should be equal to the non-zero number present. So the final result is simply m raised to the zeros. The bin power function simply does m raised to zeros. You can see the implementation here, or you can just Google it, binary exponentiation. It takes a modular 10 to the power 9 plus 1 plus 7, which is mentioned in the question. We have to take it modulo 10 to the power 9 plus 7. Yeah, so this is pretty much it. M to the power of zeros. Like for every zero I have m possibilities. Okay, so any doubt in this? This was the final question, so if you have any doubt in the entire contest, you can ask. We didn't discuss the question from Div4, Div3. If you have doubt in them, you can ask them too. Okay, so now we will end the meet. Thanks everyone for coming.